So we're going to go over the homework. Homework from section 4.1, which was just talked about pretty much reducing fractions, but it also spoke about the domain of a fraction. And the first problem on page 36, problem 2A, 2B, gives you a fraction as follows. And the question is, at what values of a variable rational expressions, at what values, and because they give a variety, are undefined. So you can look at this in two ways. You could simply say, well, when is the fraction undefined, or what is the domain of the fraction? The more common question that you'll be asked on exams, let's say, would simply be to create a domain. So that's really what I'm interested in here, to create the domain for this fraction. And remember that this fraction is not defined when the denominator is equal to 0. So the first step is to let the denominator equal 0 and see when the fraction is not defined. Now, there's two ways of solving this equation. You can either just factor it and find it that way, or I like to, since it's such an easy equation to solve, I like to do it this way and just say the square root of both sides of the equation would be plus or minus the square root of 25, which is plus or minus 5. In other words, if you look at it on a number line, this fraction is undefined at 5 and at -5. So in terms of interval notation, it's from -infinity to -5, from -5 to 5, and from 5 to infinity. This pretty much covers the entire domain. It's this area in that direction, that's this part. It's this area in the middle, which is this part. And then it's this part over here, which is that. And that's the domain of the function. If you would just simply answering the question, though, the question would be that the fraction is undefined when x is equal to +5 or -5 and -5. Okay, stop me if you have a question. Otherwise, let's move on to page 37, problem 3B. So this is a problem that you'll never see on an exam, unfortunately, because it's not, it's a basic algebra question, as opposed to, anything related to pre-calculus. It's a basic problem, just to kind of get you in the mood for reducing. W and z to the 8th. Wow, that's very fortunate. So the way I like to do these problems, as you know, is to separate this fraction into 3 parts. Part 1, part 2, and part 3. Then you can kind of get a chance to look at them, separately. So I already made a mistake. my mind was on the previous problem, but I caught it. As I've said many, many times, it's okay to make a mistake, but you have to catch the mistake. So I caught the mistake. That's a 7. And 3 into 6 is 2, and 3 into 27 is 9. That takes care of this part of it right here. Okay, then we have this, and w to the second, subtract the exponents, and you get w. And then this just cancels out. So the answer to the question is negative 2w over 9. Okay, so that's pretty straightforward. I don't know. Nothing special about that. But when we get down to problem D, that's when we begin looking at more complicated problems. So this is what we have. So let's factor this. We get 5 times x plus 7. And then the denominator, x plus 7 times x minus 7. Okay, so yeah, when we were doing factoring, I indicated to you that chapter 4 is all factoring. The whole chapter is based on factoring. So you then do this, and the answer to the question is 5 divided by x minus 7. My big problem, one of my big problems in life, is to write my 5s looking like s's. So you've got to kind of do that. And again, if there's any question about a particular problem, stop me. All right, let's not write over there. Let's not squash it in. Don't squash in your work. And we're going to go down here now. So there's the next problem. Again, page 37, problem 3F. This is problem F. And here's the problem. See, they're starting to get a little more difficult. As you know, as you go down the page, the problems get more difficult. Okay, there you go. All righty. Well, you have to factor it, period. So this is a difference of 2 perfect squares. And 3 minus a, 3 plus a, divided by okay, now we want to find the factors of 15 that will give us well, it's going to be 5. It's going to be 5 and 3. It's going to be 5 and 3, not only because it's, it doesn't look like a 15-1 situation, but also because these are, it's going to look like one of these things or something similar. So let's see, what do we get here? I would say 3 and 5. Okay, the reason is that this is 5a, and this is 6a, and we want a positive 1a, so that has to be positive, that has to be negative. So therefore, this is positive, this is negative, and that's it. And I think you could kind of see what's going on here. If you want to, you could rearrange this to look more like that, but it's not necessary because you could see that 3 plus a and a plus 3 are the same terms, and you would just cancel that out. So the answer to the question is 3 minus a divided by 2a minus 5. And if nobody is stopping me, I'm just going to roll right along. Okay, so we go to page 38 and we look at problem 4b. 5 minus x over x minus 5. I've already told you that when you get a problem like this, you could just simply say the answer is -1. I have no objection to that, but the problem is trying to kind of explain it at the same time as being simply a workbook for problems. And they're telling you how to do the problem. And the way you do it is the way we did it yesterday. Where let me just show that one more time. So this numerator can be written -x plus 5 over x minus 5. And if you factor out a -1 in the numerator, you get x minus 5 over x minus 5. And then just cancel this out, and the answer is -1. That's the reason that this is the reason why a problem like this will always be equal to -1. Problem D. All right, well, I did a great job of blotting out this. I think this is what the problem was, but I would appreciate some confirmation of that. Because I kind of wrote something on top of it, but I think this is the problem. 3 times g minus 2 divided by 2 minus g. So again, you are welcome in a problem like this to take this part of the problem away and replace it by the -1. So the answer to this problem is 3 times -1 or -3. That's it. They love this this concept. It's all over the chapter. Okay. All right, problem H. A squared minus 12a plus 36 divided by 18 plus 3a minus a squared. Well, the reason I'm hesitating is that I don't like this at all. I don't like when the a squared is over there and everything is backwards. See, that bothers me a lot. So I am always inclined to turn it around. This is always how my mind works. You don't have to do it this way. You could just attempt to factor it the way it looks there, but I don't like that. I just don't like that. It just bothers me. So I do this, and then I factor out a -1. So this will become a squared minus 12a plus.
Professor, sorry to interrupt.
Yes.
I just joined a little late because I was busy. Did you take attendance yet or not yet?
No, I didn't.
Okay, thank you.
And then I'd factor out a -1. And this would be a squared minus 3a minus 18. See, I feel more comfortable doing it that way. But, you could have just factored it the way it was. But I just don't like doing that. That's just a thing of me. Now I'm going to factor the numerator. And we want the factors of 36 that will add up to -12. So, what do we have as the factors of 36? You have 36 and 1, it's not going to be. We have 6 and 6, right? 18 and 2. We can go through all of them, but the answer is 6 and 6. Two negatives divided by, and this -1 can be put out here. Remember how I always say that? Well, that -1 can be put out there. Now let's factor that. And we get a minus 6 and a plus 3. And I believe that winds up looking like that. Yes, it does. We cancel this out, and the answer to this question is negative a minus 6 over a plus 3. There it is. I wouldn't put this negative so far over, though. I would put the negative more close to the actual fraction. Okay. I'm going to hesitate for a moment at that point and let you take a look at that. Good problem. And that's the end of chapter section 4.1. And now we go on to 4.2. Okay, so we've just gone through the section on reducing fractions pretty much. You can see that's what we were doing pretty much here, except for that original problem. And now we're going to go on to page 41. And now we go on to section, so this is the homework from section 4.2. And this was multiplication and division. Multiplication and division. So let's look at page 41, problem 2D. W squared. They love using different letters, don't they? I just like using X's. That's my thing. X's are my thing. So here it is. It's a multiplication problem for two reasons. There's two ways of determining that this is a multiplication problem. One is that they tell you multiply the rational expressions, which is another way, of course, of saying multiply the fractions. But the other way is that they put a dot in the middle there. So, and basically what you want to do is factor everything. So that's what this is. It's all factoring, this chapter. That's what this chapter is, factoring. So 2 and 2 and positive, and then 2 times W minus 3 times W plus 3 times W minus 3, and then 5 times W plus 2. And this problem was set up purposely in a way where a lot of things are going to cancel out. Okay, so you can see that this one cancels out, this one cancels out. That's it. That's all you could do pretty much. So don't leave anything behind. W plus 2, W plus 3 divided by 2 times 5 is 10. And that's the answer to the question. Anybody would like to say something here? If you want to say something about the problem, just simply jump right in. So here's problem J. More factoring. There's all factoring, and then just canceling out. That's what this is. 10 times a minus 3 squared divided by a squared minus 7a plus 12. I'm just looking at it to make sure I have everything the way it appears over there. All right, so we're just factoring everything. All righty, so, and it's easy factoring. It's not like really complicated, a complicated factoring problem. So this is a difference of two perfect squares, a plus 4, a minus 4. That's a good endeavor for you if you have some time this weekend. Simply focus on factoring. And then 5 times a minus 3, and then 10 times a minus 3 times a minus 3 divided by a and 4 and 3. Okay, there you go. So let's see what we could cancel out. Well, we could do this, right? That's good. We could do this. That's good. We could do this. Oh, look how much fun this is. And 5 into 5 is 1, 5 into 10 is 2. That's it. So now I think the most difficult part of the problem is just making sure that you don't lose anything along the way. So you have an a plus 4. You have a 2. And that's it. There's no denominator. I mean, there's a denominator of 1, right? But that's it. This is the answer to the question. Unless I made a mistake, and you're welcome to point that out, that appears to me to be the answer to the question. Moving on to problem 3F on the same page. So AB divided by AB minus 3A divided by, all right, so again, two things tell you it's division. One is the division symbol. The other one is that the instructions say divide. So this is just a regular plain old, and there's only one factor in this whole problem. So I don't know. I don't even know why I gave it such an easy problem. But here it is. It's AB divided by A times B minus 3. I factored out the A here. Oh, I forgot to flip it over, right? So you could, that's pretty obvious because we want that B minus 3 on the top so that it could cancel out here. So, I mean, it doesn't matter when you do the inverting, really, but you could do it now and the B minus 3 over the A. And again, this is the fun part. You cancel out the B minus 3s, you cancel out the A's, and the answer to the question is B over A. Pretty straightforward. Okay, problem J. Any questions so far? This is pretty straightforward stuff here. All right, let's go back up here where I have a little more room. And problem J. So x squared plus 7x plus 12 divided by x minus 5 divided by x squared plus 9x plus 18. X squared minus 7x minus 10 plus 10. Caught that. I'm just looking at the problem again, making sure I have it. Okay, x squared minus 7x. All right, there it is. this time, let's get rid of the division immediately. So let's rewrite the first fraction. Okay, so all I did was flip over the second fraction. And now you just have to factor all this stuff. That's okay, so x plus 3 times x plus 4 divided by x minus 5 times x minus 5 times x minus 2 divided by x plus 6 times x plus 3. All right, and what you should do is check your own work, check my work to your work, and make sure that neither one of us made a mistake. All right, let's see what we could do here. Well, you could cancel out this and this, this and this. That's about it. So you're left with x plus 4 times x minus 2 divided by x plus 6. And that's the answer to the question. And that's division of rational expressions, division of fractions. The third and final part of the homework, which is section 4.3. All right, so the first thing we're adding are fractions which have the same denominator. So this is my own indication here. It doesn't say this in the chapter. Same denom in a tor. Same denominator. Problem F. Whoops, excuse me. Problem L, apparently. 2L. On page what? 45. 45, 2L. And the problem is 15 over 4x minus 3 over 4x. Well, the rule is the denominators must be the same before you can add or subtract. So that's exactly what we have here. And it's going to be 15 over minus 3 over 4x, which is 12 over 4x. And 4 into 4 is 1, 4 into 12 is 3, and the answer is 3 over x. Okay. Everybody clear on that? All right, here's problem N on the same page, problem N. 8y over y squared minus 64 minus 7y minus 8 divided by y squared minus 64. So incidentally, this negative sign is not the negative sign of the 7y. That negative sign is kind of out here. And that could be a source of problems. So this is what I would suggest. First of all, the denominators are the same. And I would suggest factoring that. Save some time. The denominator is y squared minus 64, which is going to be y minus 8 times y plus 8. But in the numerator, you have 8y minus. Now that, again, I said that minus does not belong to the 7y. It belongs to the whole numerator of the second fraction. That's what the problem really says. And then you get 8y minus 7y plus 8 divided by y minus 8, y plus 8, which equals 8y minus 7y is y plus 8 divided by y minus 8 times y plus 8. And you can see how nicely this problem was constructed by whoever constructed it, by whomever constructed it. And that's equal to 1 over y minus 8. This is problem P. X squared over x minus 5 minus 2x minus 35 divided by 5 minus x. So you can see the difficulty in this problem. I mean, I could see the difficulty. I guess you can also. So first of all, the denominators are not the same. These denominators are not the same. So I don't know, I would, see, you're going to have some problems when you want to combine the two fractions, right? So you're going to have to get these denominators to look the same before you can really do anything. So this is that same situation. So let's rewrite this. Let's make this into negative x plus 5. In other words, I just took this and switched it around so it looked like that. And now let's factor out a negative over there. So watch carefully. Here's where it gets tricky. Here's where it gets a little tricky. Because you get this. Now I'm going to factor out the negative 1 over here. And that'll give you negative 1 times x minus 5. Well, that's great because we just created the same x minus 5 in both places, right? The only trouble is we have a negative over there. What do you want to do with that negative? Negative 1, what do you want to do with that? Normally, we would take it and put it over there. You know how we've been doing that? We like to put it, instead of in the denominator or the numerator, there is a sign already there. So any suggestions?
Can we make it addition?
Tell us how. How?
A minus 1 times a negative 1 is a positive 1.
So in other words, take this negative, take that negative, and make it positive.
Yeah.
Perfect. That's exactly right. Beautiful. Positive 2x minus 35 over x minus 5. That's exactly how you do it. Very, very nice. Okay, now we have the same denominator. We don't have a freaky negative, double negative to worry about. Basically, what we did was take this negative and say, all right, we don't like to put it down there. We like to put it over there. If we did, though, we'd have two negatives next to each other, which would become positive. And that's what we did. And now everything looks very nice. And this is x squared plus 2x minus 35 divided by x minus 5. And if we factor the numerator.
Sorry, Professor, can you lower the camera?
Sure, thank you very much for telling me. I appreciate that. This is a 7. This is a 5. Guess which one is going to be the negative, right? Guess which one is gonna be the negative? And it works out anyway because, whoops. Works out anyway because we do have a positive 2. So there you go, and then this drops out, and the answer is x plus 7. And that's it. Very nice problem. Not, extremely, let me silence my phone. I had it on. Okay, now it's off. Okay. And that's all I gave you on adding fractions with the same denominator. And the reason basically is that the problems get more difficult as we go on. And those are the ones I really want to focus on. So different, unlike, let's call it unlike denominators. So, the previous was like denominator, same denominator. This is unlike. And we look at page 47, problem B. Let's see what this looks like. 4m plus 2 divided by 3m plus 12 minus m minus 2 divided by m minus 4. Okay, so let's, I don't know if I'd factor this, but I'd certainly factor this. So in this problem, the next step is going to be to keep this the same. I don't even know if that's such a good idea, but I'm doing it anyway, and you get 3 times m plus 4. Oh, really? Yeah, that's even more difficult than I thought. Okay, well, there you go. All right, so that's what we have. We need to find a least common denominator. We need to find the least common denominator. So the least common denominator had, well, in other words, the least common denominator, to put it very simply, the least common denominator has to have everything that the old denominators had, period. When you create the least common denominator, if there's a 3 here, the least common denominator has a 3. If there's an m plus 4 here, the least common denominator must have an m plus 4. If there's an m minus 4 over there, the least common denominator must have an m minus 4. Is that clear? I think that's the most important part of the problem. Is, looking at the denominators, creating the least common denominator. Okay, now, so here we have 4m plus 2. But to get from this denominator to this denominator, we say, what's missing? What do we have to multiply by this fraction in order that this denominator will look like that denominator? And you can see that what's missing here, that we have here, is the m minus 4. So therefore, we have to multiply. How shall I do this? Do this in such a way that we don't confuse everybody. So in other words, this is what we're doing. We're multiplying by m minus 4. We're multiplying by m minus 4. So that will give us that denominator. And then over here, we have m minus 4 times 4m plus 2. So this is the key right here. Finding the LCD and then going from the original fraction down to the fraction which has the LCD. So here's what I started with, but this is what I needed. So I therefore need to multiply by m minus 4 over m minus 4. Now let's look here. Now here, what do we have in the least common denominator that we don't have in the original denominator? We don't have a 3, so therefore this must be multiplied by 3, numerator and denominator. You can't just, throw in a 3 there. It's got to be top and bottom. That's good. Now we're missing the m plus 4, so we need to multiply by m plus 4 over m plus 4. Remember, it's always the number over itself. Let's put this in parentheses. And this is what so this becomes 3 times m minus 2 times m plus 4. And now we're ready to go. I'll pause there for a moment, because that was a little complicated right there, right? A little complicated with doing that. All right, so now now you have to grind it out. Now you have to just grind out the whole problem. In other words, multiply these two binomials. So let's do that. That's 4m squared minus 16m negative. So we multiply. Let me do this in an organized way rather than just trying to wing it like that. So m times 4m is 4m squared. M times 2 is 2m. Then negative 16m and negative 8 over 3 times m plus 4 times m minus 4. And before we even go over here and do this, let's see if we can simplify this, right? So this becomes 4m squared minus 14m minus 8. It's turning out to quite a problem, isn't it? I don't even know if this can be factored, but who cares? Right now, we don't care about that. We're just, we're just multiplying up here to kind of simplify that. Minus, now, let's multiply these two binomials and then multiply by the 3. Right? So this is 3 times m squared plus 2m minus 8 over 3 m plus 4 m minus 4. So what I just did was to multiply these two binomials to get this. And that, I think, works out pretty well. Okay. Now, what's next? Wow, this is taking up the entire board. Okay, so we now have the same denominator. So we don't have to write two different fractions. We could just do this. All right, so here we go. So 4m squared plus 2m. No, let's, we're down here. We're not up there. We're down here now. Right, so let's get rid of this. 4m squared minus 14m minus 8. Now,
Down a
let's-
little bit,
Can't see.
please.
whoop. My apologies, my apologies. My apologies. Yes, I should be aware of that stuff, but I'm so focused on not making a mistake here, you know, that's like pretty heavy stuff. Okay, so anyway, let's make this negative here with the 3. So this is going to go with the 3. So negative 3 times m squared, negative 3 times positive 2m, and negative 3 times negative 8 is positive 24. The way we'll know if we're doing this correctly is if the numerator can be factored. If the numerator can be factored, then we know that all of this is coming out right. Okay, so 4m squared minus 3m squared is m squared. Now get rid of it. Negative 14m, negative 6m is negative 20m. Get rid of it. We don't need it anymore. Negative 8, positive 24 is positive 16. Oh, okay, good. It'll work. This is where we are. Wow. Now let's factor the numerator. Can the numerator be factored? It can be, because I just factored it in my mind. The factors, oh, now I lost it. The factors of 16 that will give us 20, really? Maybe it doesn't. Who knows? 8 and 2, no. 16 and 1, no. 4 and 4. Yeah, you'd think it was 4 and 4 in there somewhere, but it's not. Okay, let's make sure we have the right signs here. I don't know, it looks like that's it. This can't be factored. Unless somebody did it. Did somebody do it in the homework and was successful? Otherwise, I think this is the answer. That's my contention. I contend that this was the answer. That's my contention. Here's page 47, problem D. And this problem is 4c over c minus 3 minus 1 over c plus 1. They don't have to always work out perfectly. You know, you like it to everything to cancel out, you know, all that stuff, but sometimes it doesn't do that. Okay, so the first thing we do is recognize that these are different denominators, and therefore we need to create a least common denominator. So this denominator contains a c minus 3, therefore there will be a c minus 3 in both places. It has a c plus 1, therefore we have a c plus 1 and a c plus 1. Now to get from here to here, we're missing the c plus 1. So you're going to multiply this by c plus 1 over c plus 1. And that will come out, well, let's just leave it as that, and then we'll multiply later. So that's what I did there. Here, you're missing the c minus 3, so we need to multiply by c minus 3 over c minus 3. And that's what you have there. And now we could put it over the same denominator, which is c minus 3, c plus 1. And let's see, 4c times c is 4c squared. 4c times 1 is 4c minus c plus 3. And now let's try to simplify that numerator. So 4c squared, and this becomes plus 3c plus 3 over c minus 3, c plus 1. Now, can that be factored? That's it. Can't be factored. Okay, let's go to the next problem. This is an important problem, I think, because I remember that I put this next problem on the test. So this is kind of an important problem that I'm now going to do, because I think this is the problem that I put on the test related to this topic last semester. It's problem H. And here it is. 3x squared minus 8y squared divided by x squared minus x squared minus 2xy, and this minus okay, there it is. Well, I would suggest factoring the denominators. That's the first step. Well, I'll tell you this, of all the things, we were just flying through the homework, and then we hit adding adding fractions with unlike denominators, and we just hit a stone wall. Everything became really, really complicated. So let's factor the denominators. And let's see what we get. Be nice if something worked out here. Okay, we get that. This became this. And let's factor out a y times x minus 2y. Whoa, look at that. Very interesting. So far, it doesn't look quite that bad. Factor out the y, because there's a y in both terms. So factor out the y, you get x minus 2y. Okay, good. Now the least common denominator is going to have an x. It's going to have a y. And it's going to have an x minus 2y. And there it is. That's the least common denominator. Not bad. So far, pretty good. Right? Now, the old denominator, the new denominator. What's missing? Going from here to here. The y. Therefore, we need to multiply numerator and denominator by y. And this will give us 3x squared y minus 8y to the third. Again, this is what we have. The old denominator, the new denominator. We need a y. You put that in. 3x squared y, that's this part. And then 8y to the third. Okay. Now, what's missing from here going down there? The x. So keep that negative. This becomes 3x squared y and then minus x to the third. I see what's happening here. Okay, you're gonna love this. Okay, so 3x squared y minus 8y to the third minus 3x squared y. I'm doing the negative now here, and now here, plus x to the third divided by xy times x minus 2y. Now, fortunately, we get lucky, and this cancels out with that. That's good news. And that will give us x to the third, negative y to the third, plus x to the third over xy.
Professor, can you?
Yes. xy times x minus 2y. Now let's take this and flip it around. So here's what we have. Here's my
Isn't it the difference of cubes?
oh well, I was gonna show you that I was not kidding about my extra credit. Yes, it is. It's a difference between two perfect cubes. Who said that?
Rose?
Rose, you're like flying today. Yes, it's a difference between two perfect cubes. The two perfect cubes are x squared, x to the third rather, minus 2x to the third over xy times x minus 2y. Now, let's factor this. We know how to factor a difference of two perfect cubes, so let's do it. So x minus 2y, which makes sense, because look what you have in the denominator. So that's going to cancel out. Times x squared, now plus x times 2y is plus 2xy plus 4y squared. That's the numerator, and the denominator xy times 2 times x minus 2y. That cancels out, and the answer to this problem is x squared plus 2xy plus 4y squared over xy. That's the way I like to see a problem work out. It just came out beautifully.